We're going to be modeling linear relationships by reading the question, writing an equation, and then graphing the equation. Okay? Some of your questions tonight on your homework, some of your problems are going to have questions at the end. This one does have a question, however, I'm not a big fan of this question, so I'm going to write a different question for you guys to answer. Okay? So can you guys cross off that question, please? And we're going to write a different question down to answer there. Here's your question. Did I write 40? This is supposed to say 50, sorry. Okay. All right, so here's your problem here. We have this band booster club. It says they are selling t-shirts and blanket wraps to raise money for a trip. The band director has asked the club to raise at least $1,000. The Booster Club president wants to know how many t-shirts and how many blanket wraps the club needs to sell to meet their goal of $1,000. T-shirts cost $10 each. Blanket wraps cost $25 each. Write an equation that describes the problem and then graph it. After we do that, then we're going to answer this question. If they sell 50 t-shirts, how many blanket wraps would they need to sell? Okay. So first thing we're going to do is identify some important information here. If you have a highlighter or a colored pen, that would be good to do some highlighting or some underlining with. Okay, so what two things are they selling here? Okay, how much is every t-shirt? $10. Okay, $10. So each t-shirt is $10. You guys also said what else are they selling? $25 Okay, blanket wraps for $25. Now, what's their total goal?
$1,000.
Thank you. Okay, $1,000. All right, so we have two different things that they're selling here. Do I know how many shirts they're going to sell?
No.
Do I know how many wraps? No. Okay, so I'm going to let those numbers, the number of shirts and the number of wraps, be two different variables, okay? So, to set up this problem, first what I'm going to do is I'm going to let my first variable, x, be one of the things. Now, which thing do you want x to be, the shirts or the wraps? Shirts, okay. So, x is going to be the number of shirts that they sell. Okay, my other variable is going to represent the other item that they're selling, which is going to be the number of wraps, blanket wraps, whatever that is. To me, it sounds like a Snuggie, but I don't know. Okay. All right, so I have these two things here, right? Now, I'm going to write an equation to represent this situation. So, here's how they find their total. They take their number of shirts and they multiply it by how much each shirt cost. How much was each shirt? 10. So 10 times x, that's my total amount for my shirts. Then I'm going to add that with the total amount for the wraps. Well, how much did each wrap cost?
25.
So I'm going to say 25 times y. Yeah, and that equals what they're trying to raise, $1,000. Okay, now I want you guys to look at this equation. What form is this equation in? You guys, we just reviewed the 3 different forms, right? Standard? Okay. So, what was in our notes? What did we write down about how to solve, like how to graph from standard form? What was like the first thing we wrote on the front of the flap?
We wrote A.
What notes do we write to ourselves to help us? Cover and solve, okay? So, here's what we're going to do. We're going to cover and solve to find our intercepts, okay? So, the first intercept we're going to get by solving 10x equals 1,000. I should actually move this because I need to number that right there. Sorry. Let me move this to a different place. I don't want that there. Okay, I'll put it over here. Okay, so 10x equals 1,000. So what am I going to get when I solve that? Let's divide by 10. What's 1,000 divided by 10?
100.
I think sometimes you guys just say like random numbers without actually trying to like solve the problem. I think you guys just guess. Okay, it's 100. 10 times 10 does not make 1,000. Okay, so next we're going to cover and solve the other one. So now we're going to cover and solve right there. So our equation is 25y equals 1,000. Let's divide by 25 on both sides. And we get, for a y-intercept, y equals 40. Okay, now, I need to graph each of those intercepts. Okay, now I know that this graph came out super light, but there's actually supposed to be some lines in between the dark lines. I don't know if you guys can see those. I'm going to trace mine over. Okay, if you want to take a pencil and trace yours over too, that might be good. All right, so I want to scale my graph so that I make sure that I can actually have enough room to write the x-intercept of 100 and the y-intercept of 40 onto my graph. Okay, so let's think about on my x-axis, this is my x-axis, and I'm going to put some words here to say what that represents. X is representing sandwiches. So x-axis represents the number of sandwiches, right? Oh, sorry.
What?
Sandwiches. I'm thinking of the second problem. I'm sorry. Not sandwiches. What is X representing? Shirts. Sorry. I'm thinking of problem 2. Obviously, what is problem 2 about? Sandwiches. Okay. All right. So X is representing the number of shirts. Okay. And what is our y-axis here representing? Blanket wraps. Yeah, not sandwiches. Okay. Now, let's try to figure out how to scale this so that way our scaling, we can accommodate 100 for our x-intercept and 40 for our y. Okay, so if I count here by tens, I can probably fit it. I tried earlier to count by fives and I got to about like 75 and I ran out of room. So fives doesn't work, okay? So let's count by tens. Okay, and we're going to put our x-intercept right there at 100. Does that make sense, what we did there?
Can we skip a line?
What's that?
Like, can we skip a line? The little line.
Next, let's go ahead and scale the y-axis. I could do the y-axis by tens, but then, like, my y-intercept's going to be right here. if I do it by tens, I want to try to take up as much space as I can. So maybe what I'll do here is I'll scale it by a smaller unit, like 5, since I can fit by 5s here. Okay, so 5, 10, 15, 20, 25, 30, 35, 40. Okay, so that way, then, like, because if I scale it by something like tens, then my graph might end up being really teeny tiny and hard for me to read. So I want to try to, like, pick a good scale, if that makes sense. Okay, so the smaller my units of measurement are that I'm scaling by, that will make the graph actually bigger, which will make it easier for me to see. Okay, so that's why I counted this one by 5s. All right. Okay, now let's go ahead and connect. So take your ruler. Okay. All right, so now we have our graph. Okay, now the line on the graph represents all the possible combinations of shirts and blanket wraps that make $1,000 or that total $1,000. Okay, so any point on this line represents like a number of shirts and a number of wraps that when I calculate that total, it makes $1,000. That's what the points on the line represent, okay? So I can use the line to answer questions like this one. So this question says, if they sell 50 t-shirts, how many blanket wraps do they need to sell? Well, let's find where 50 shirts is, because shirts is on our x-axis, right? So where is 50 shirts? Right here. And let's go up to our line and see what that corresponds with on our y-axis, because y is the number of wraps. So how many, if they sell 50 shirts, how many wraps are they selling? 20. So the answer to this question is they will sell 20 wraps. Does that make sense how I use the line to help me find that answer? Okay. All right, so problem number 2. Sandwich shop sells sandwiches for $5 each and bottles of water for $1 each. The owner of the shop needs to earn a total of $100 by the end of the day. Write an equation that describes the problem, then graph. Make sure to label both axes with appropriate titles. Then use the graph to determine how many sandwiches the shop must sell if no waters are sold. Okay, so let's highlight important stuff. What are they selling here?
Sandwiches.
And how much are the sandwiches? $5. Okay, what else are they selling? How much are those? $1, right? Okay, what's our total we're trying to sell here? $100. Okay, so $100 total. All right, so we have 2 different variables, right? We're selling sandwiches, we're selling water bottles. We don't know how much of either of those we're selling, so we're going to let both of those be our variables, okay? So let's let X be which one? Sandwiches. And let Y be what? Okay, now we're going to write an equation to represent the situation. So how much is it costing for every sandwich? 5, right? So 5 times X plus they're making money off the water bottles. How much is each water bottle? 1. So 1 times Y
Equals 100.
equals the total they're trying to make. $100, right? Okay, now, what form is it written in? Standard. So let's cover and solve. Okay, so let's cover up here and solve that. So when we cover and solve, we get 5x equals 100. So what is x? 20? Okay. Now let's cover and solve for y. Well, isn't that just y equals 100? Okay. All right. So now let's do our labeling on our graph. Okay, so our x-axis is representing what? Shirts? Just kidding. What is it?
Burger.
Sandwiches, right? Okay, what's our y-axis representing?
The water.
Water bottles. Okay, let's do some scaling, okay? I'm going to draw in my lines that disappeared when I photocopied this for you guys. There were supposed to be some other lines here. Okay, and then that way then I can think about my scaling. So look at what your x-intercept is. Your x-intercept is pretty low this time. It's what number?
5.
20?
5. Oh wait, no.
Yeah,
it's not.
I mean the intercept itself is 20. So let's think about what I should scale by. I could scale by 5, 10, 15, 20. Could I scale by a smaller unit?
2.
Let's see if it fits. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Would that fit? Yeah. So let's scale by that unit. I like that better because it's taking up more of the graph. And I want to utilize the graph here that I have, so I'm going to scale by the smallest unit possible, which would be 2s. Okay. Now, my x-intercept is 20, so I'm going to put my x-intercept right there at 20. Okay. Now, what about for water bottles? What was my intercept for water bottles? Yeah, so am I going to be able to scale that by 2s?
By 10.
Yeah, or even 5s? No, by 10s, right? 10, 20. Okay, and so now I can put 100 right here. Now, we're going to go ahead and connect your x and y intercept together. Now, why do I not extend the line beyond these 2 points? Can I get a negative number of sandwiches or negative number of water bottles that I'm going to sell? No, so that's why I don't extend it beyond those 2 points, because that represents the negative things. Okay? All right, so let's see if we can answer the question. It says, use the graph to determine how many sandwiches the shop must sell if no waters are sold. Well, if no waters are sold, that means we're selling how many water bottles? 0. So 0 water bottles are right here. So let's go to the line for sandwiches. Now, if I go this way, that's water bottles. I'm trying to find out how many sandwiches, so I need to go over here. So how many sandwiches?
4.
If I sell 0, then I have to sell how many sandwiches? 20. So the answer to this question is 20 sandwiches. Okay, now, what if I asked you guys how many sandwiches do they have to sell if they sell 50 water bottles? Well, if they sell 50 water bottles, on the water bottle side, we would go to 50, and go to the line, and then go down to see what number of sandwich matches that. So what number is that? 10, right? Okay, what if I asked you how many sandwiches do they need to sell if they sell 70 water bottles? So you would go to 70 on the water bottle side, go over, and then go down. How many sandwiches is that? 6. Is this making sense how we use a line to help us answer questions? Okay, so what if I asked you how many water bottles do they need to sell if they sell 14 sandwiches?
30.
Yeah, 14, then go to 30. Does that make sense what we're doing here?
Yeah.
Okay, so we're using the graph to answer some questions. This is what your homework tonight is like. Okay, all right, I want you right now to write down your homework assignment. Your homework is textbook, page 247, numbers 1 through 15. Okay? All right, make sure you get that written down.